When we talk about industrial control systems, there is one standard that really is the bedrock for all security: IEC 62443. Today, we are going to break down Part 1, the document that sets the stage. It defines the language, the concepts, and the models for protecting our most critical infrastructure. If you're an engineer, an operator, or a security pro in the OT world, this isn't just nice to know, it's essential. So let's jump right in.
Now, before we get into the standard itself, we have to get one thing crystal clear. In the world of information technology, or IT, security is all about protecting data. Confidentiality is everything. You can think of it like a bank vault. But in operational technology, or OT, we're dealing with physical processes, and here the game completely changes. The top priorities are availability and safety. A data breach in IT is bad, no question, but a failure in OT, that can cause real physical harm, damage the environment, or even take down the entire power grid. This huge difference is exactly why you can't just slap an IT security solution onto an OT system and call it a day. It just doesn't work, and it's why we need a specialized playbook like IEC 62443.
So here's our game plan for today. First, we'll talk about the unique security challenge in OT. Then we'll dive into how Part 1 of the standard builds the foundation for everything else. We'll cover the common language it creates, the core models it uses for defense, and how it actually measures security. And finally, we'll tie it all together and talk about why this is so critical for keeping our industries running safely. Okay, so the systems we're talking about here are literally the engines of our society. They run our power plants, our water treatment facilities, and our factories. The big challenge is that most of these OT systems were built for reliability, meant to last for decades, long before anyone was seriously thinking about cybersecurity. But here's the problem. As we connect everything to networks, these systems have become huge targets. A vulnerability here doesn't just mean losing data. It can lead to catastrophic physical events, putting public safety and even national security at risk. And that is exactly where IEC 62443 comes into play. You have to understand, this isn't some generic IT framework they've tried to force-fit. It's a comprehensive standard built from the ground up specifically for industrial environments. We're focusing on Part 1 because honestly, it's the Rosetta Stone for the entire series. It's the key that unlocks all the concepts and the terminology you'll see everywhere else in the standard. So, what is it officially? Well, IEC 62443 is the leading global standard for securing what we call industrial automation and control systems, or IACS. And what makes it so special is that it's not just about security in a vacuum. It's about security within the context of industrial operations. It's completely tailor-made for these environments, where safety, reliability, and keeping things running 24/7 are the absolute non-negotiable priorities. The standard is broken down into 4 main parts, and it's actually pretty logical. Part 1, which is our focus today, sets up all the general concepts. It's the foundation. Part 2 gets into policies and procedures. You can think of it as the how-to guide for running a security program. Part 3 deals with system-level requirements, and Part 4 drills all the way down to the security of individual devices and components. They all build on each other, but you absolutely have to start with Part 1.
The best way to think about it is this. Part 1 is the instruction manual. Imagine getting a complex piece of furniture with no instructions. You'd have no idea what the parts are called or how they fit together. That's what the rest of the standard would be like without Part 1. It gives you the vocabulary and the core ideas you need before you can even think about building your defenses. It really is the foundation everything else is built on.
Okay, so one of the biggest things Part 1 does is create a common language. And you might think, why is that so important? Well, just think about it. You've got the people who own the plant, the vendors who make the equipment, and the integrators who put it all together. They all have to work together on security. If they're all using different terms for the same thing, it's just chaos. So IEC 62441 provides that essential standardized vocabulary so everyone is on the same page.
All right, let's build a little story here using these key terms. Everything begins with an asset. An asset is basically anything, physical or digital, that has value and that we need to protect. So for our story, let's picture a critical water pump at a city water treatment plant. That pump is our asset.
Now, that asset of ours, our pump, can have a vulnerability. A vulnerability is just a weakness, a flaw that someone or something could take advantage of. In our story, this critical water pump is running on old software that hasn't been patched in ages. That outdated software, that's a huge vulnerability, just sitting there waiting to be exploited. Okay, so we have a vulnerable pump. Next, we need a threat.
A threat is anything that could potentially cause a bad incident. Now, it could be an accident, sure, but in cybersecurity, we're often talking about a malicious actor. So here, our threat is a hacker who's actively trying to get into the plant's control network, and they're looking for exactly the kind of weakness our pump has.
And all of this brings us to the big one, risk. Risk is what you get when a threat successfully exploits a vulnerability. It's the potential for something bad to happen. In our story, the risk is that the hacker gets in, shuts down our water pump, and disrupts the city's water supply. See how that works? Asset, vulnerability, and threat. They all connect to tell the complete story of risk.
All right, so now that we're all speaking the same language, let's talk about structure. How do we actually build our defenses? IEC 6243-1 introduces some really powerful models that are absolutely essential for designing a secure system architecture. Let's look at the most important ones.
The most fundamental model here is called zones and conduits. The whole idea is to stop thinking of your network as one big, flat, open space. Instead, you partition it. You group assets that have similar security requirements together into what's called a zone. And then, any communication channel that connects these zones is defined as a conduit. This lets you put strict security controls, like firewalls, at the boundaries. It's the core idea behind classic OT architectures, like the Purdue model.
And this is the payoff, right here. The security outcome is night and day. On a flat network, if an attacker gets in at one point, it's like a wildfire that can spread across the entire system. The risk is incredibly high. But when you segment your network with zones and conduits, a breach can be contained. You can stop the spread within a single zone, which dramatically reduces your overall risk.
This idea of zones and conduits leads us straight into another core concept, defense in depth. Security should never be about a single magic bullet. It's about creating multiple overlapping layers of defense, like the layers of an onion. It starts with physical security, things like fences and locks. Then you add network controls, like firewalls and those conduits we just talked about. Then you harden the devices themselves. And finally, you secure the applications with things like user access controls. If one layer fails, you have others to back it up.
So we've got the languages, we've got the architectural models, but how do we know if we've done enough? How do we know if we're secure? This is a huge innovation in IEC 62443. It gives us a formal, measurable way to define and check the level of security a system actually needs.
This is done using something called security levels, or SLs, and there are 4 of them. SL1 is your basic level. It's designed to protect against accidental mistakes. SL2 steps it up to protect against intentional attacks using simple tools, like from a script kiddie. SL3 is where it gets serious, defending against sophisticated attackers like organized crime. And SL4, that's the highest level, designed to stand up to a targeted attack from a group with nation-state resources. Let's make this super practical. Imagine we're securing a power substation. SL1 protection might be nothing more than a simple padlock on the front gate. But if that substation is critical to the grid, you're going to need something much stronger, say SL3 protection. That would look more like a multi-factor system with a badge reader, a PIN code, and a fully monitored alarm system that logs every single person who goes in and out. That's how security levels help you define how robust your defenses need to be.
And this next point is absolutely crucial. The standard makes it very clear that security is not a one-and-done project. You can't just set it and forget it. It has to be a continuous process that is woven into the entire life of a system. This is what we call the security lifecycle. It means security can't be an afterthought you tack on at the end. It has to be designed in from the very beginning. It has to be checked during implementation, managed every day during operations, and actively maintained with patches and updates. Which, as you can imagine, is a huge challenge for OT systems that were built to run untouched for 20 years. And it even includes decommissioning, making sure you securely dispose of old equipment so no sensitive information is left behind.
Okay, so let's zoom out and bring it all together. Why do all these foundational ideas, the language, the models, the measurements, why do they really matter? Well, the impact is massive. It scales from the safety of a single worker on a factory floor all the way up to the security of an entire nation. When you get right down to it, applying these principles protects our critical infrastructure from attacks like ransomware and sabotage. It ensures the physical safety of workers and the public by preventing industrial accidents. For many organizations, it's also key to complying with new regulations like NIS 2. And by creating that common language we talked about, it allows the entire industry, vendors, operators, everyone, to work together to build a more secure future for all of us. So there you have it. We've just walked through the essential foundation from IEC 624431. You now have the core language, the architectural models, and the metrics to measure security. This is the starting point for building a solid defense for any industrial system. The big question is, what are you going to build on top of it? In our future explainers, we'll dive into the other parts of the standard to help you answer exactly that.